Can you see my screen?
Yes, sir.
So I think yesterday we are already in here. Okay, we are already in here, and then so I think I have explained this one yesterday. I have explained this one yesterday, and okay, and this is the this is why material science and engineering is important. This is why material science and engineering is important. First, because to we want to ensure the performance. The performance is um, justified with the cost lah. Okay, for example, if you want to make car, okay, you want to make car, so so the car must have a certain amount of a certain period of time where it can be where how long it can last, for example, for how long it can last. The the requirement. Kejap, the requirement of the car. So what is the purpose? What is the purpose of the car? So to carry passenger and to make sure that our journey is uh, getting easier lah, faster, getting easier, and bring you to the destination that you want to be. Okay, so is it possible? Is it possible for the car to be made from plastic? Okay, to be made from plastic, because if you are using plastic to make the car, the cost will be very cheap. Okay, okay. However, can it last long? So because plastic, the properties is not that strong, so plastic is not applicable. So we can use metal. Okay, we use metal. So there are many types of metal. We have titanium, we have gold, we have aluminium, and we have any other metal alloy. Okay. So what types of metal that is suitable to make car? So maybe it is suitable if you are making the car using titanium, because titanium is high strength, corrosion resistance is very high, something like that. And then so this can be made using titanium. However, if you compare titanium with, for example, with another metal, for example, alloy or aluminium, titanium cost the cost for titanium is very high. So the performance is met if you are using titanium, but the cost is not desirable because the cost is too high if you are using titanium. So what they use is they use another type of metal, which is aluminium alloyed with another thing. Okay, so that is the requirement. Okay, and this requirement, so this properties is related to this performance. The performance of this material is related to the microstructure or the structure of the structure of the material. Okay, the reason why plastic is low in strength is because the arrangement of the atom is not densely packed. But the reason why metal is stronger because the arrangement of the atom is well packed. Okay, and then so because the microstructure affect the performance, so the microstructure also will affect the processing method of the material. So the stronger the material, the higher the difficulty of the processing method. The difficulty means, for example, let's say you have plastic and then you have metal. So plastic is not difficult to process, perhaps only at 100 degrees Celsius or 200 degrees Celsius, the plastic can melt already. However, for metal, you need higher energy. When you need higher energy, that means you need higher amount of heat. So maybe you require 2000 degrees Celsius in order to melt that metal before you can cast into product. So the more the better the better the microstructure in terms of the arrangement of the atom, the higher the degree of a processing method. So this is how the microstructure, the processing, and the properties of material is related. Is related from one to another. Okay, this is all related. So you must have the logic about why you are using this material, why you are using this material, something like that. It is possible if you want to make car using plastic. For example, you need to use a high strength plastic, but still it won't be able to handle the crash. Okay. Okay, engineering materials can be classified into several types. First is metal and alloy. Metal and alloy. Metal is metal lah. In Malay we call it besi. Alloy is a mix. The mix of besi, mix of metal. I'm sorry because actually I am working parallelly with other things. So at the same time I am giving lecture, and at the same time I am doing something else. I'm working. I mean, something else is working. It's not just chatting whatsoever. I have something else to do because it is week 1. Typically, week 1 until week 5, all lecturers will be busy. Okay, and then the second. Okay, so I repeat again. Metal is besi lah, besi, and then alloy is the mix of these things. So you have, for example, aluminium plus with another type of metal. So this will become alloy. Okay, and then we have ceramic, ceramic and glass. Ceramic and glass. This is first. This is second. So ceramic, for the example, is like vase. I don't know why you call it vase or vase. Porcelain like plate. Um, ma. That is ceramic. A glass like a window glass, transparent window glass, mirror. So that is in this category, the second one. Also ceramic, this is traditional ceramic, the one that is made from silica, tanah liat tu silika lah, clay. This is what we call, but the science name is silica, the element of the material. Okay, silica, and this is the traditional ceramic. So we also have advanced ceramic. Advanced ceramic, for example, titanium oxide. So when you add oxygen to this titanium, it will become titanium oxide, and this is advanced ceramic, which is higher strength. This advanced ceramic, the strength is higher compared to metal. I repeat, advanced ceramic, the strength of the advanced ceramic is higher compared to metal. Ceramic can cut metal. Metal not necessarily can cut ceramic. Okay, so this ceramic can cut metal because it is high strength. But we will go to these things in detail later in another chapter. Okay, and then we have the third group, which is polymer. Polymer, it has two types. First is plastic. It has three types. I simplify as three types. One is thermoplastic. Second is thermoset. We will learn this one in detail later. And then third is rubber. So thermoplastic, for example, water bottle. The light and transparent and also very low strength. Okay, this is thermoplastic. Thermoset is high strength. For example, epoxy, polyester resin. You can Google this if you want to see how this material looks like, but we will go to this thing later in detail. And then we have rubber like tire lah, car tire. So that is rubber. But the car tire is actually a synthetic rubber. We have I don't know what it's called. Maybe we call it natural rubber. Natural rubber is the rubber that comes from the tree, from the rubber tree. That is natural rubber. The synthetic rubber is the natural rubber which has been added with other things. Then it will become synthetic rubber. So this synthetic rubber the car tire is actually synthetic rubber. Okay, and then we have for composite. Composite is composite composite is a mixture of two types of material similar like alloy, but this alloy is mixed a liquid metal plus liquid metal. Composite uh, composite is mixed between liquid plus a solid. That is how composite is made. Liquid plus solid, a liquid material plus solid material. But we will go in detail later. And then semiconductor. Semiconductor is the material that will behave between conductor and inhibitor. Okay, and then we have smart material. Smart material is the material that is smart. For example, this material will react according based on the environment. Based on the environment, for example, clothes or t-shirt. Your t-shirt can change the color, when it is exposed to lights or when it is in the dark room. So when it is in the dark room, the color of your t-shirt will be black, for example. But when it exposed to lights, the color of the t-shirt will be changed to something else, to another color. Okay, but I can show you later about this thing. This chapter is just the introduction. Okay, this is an example of a ceramic, the thing that I told you before, like silicon oxide. Okay, ceramic. This is silica from clay lah, and then you mix, you do treatment, then it will become either amorphous or crystalline. So what is amorphous and what is crystalline? So amorphous or also known as non-crystalline. Crystalline is crystalline lah. The opposite things to crystalline is non-crystalline, or also known as amorphous. So the amorphous refers to the arrangement of atom randomly. So the atom was arranged randomly, very chaos lah. No specific order in terms of the arrangement of the atom. However, for crystal has an order. The arrangement of the atom is in order. Faham tak? In order. In order means in a good way lah. Organized. Okay, organized. This one disorganized. Arrangement of atom disorganized. This one is organized. If you have any question, you ask. If you don't understand, you ask. This is the application. So some use plastic for car. Some area use plastic. Some car use aluminum. Some car use ferrous alloy. Some car use rubber. Okay, and then this is how the engineering materials. The 6 types of engineering material classification is applied to make something. For example, this to make car. Okay, we go to the first engineering material. First is metal and alloy. Metal and alloy. So the definition of metal and alloy, it is an inorganic substance which composed of one or two metallic elements. So as I said, this alloy is a combination of one metal plus one metal. Okay, and may also contain small concentration of non-metallic element. Non-metallic element, for example, this one carbon, nitrogen, oxygen. Typically, this one lah, metallic element. So the properties of metal and alloy are strong and ductile at room temperature. Strong lah, metal lah, of course lah, metal is strong and ductile. Ductile means in Malay it is mulur. Mulur mean it can be bent. It will not. Uh, it will not. It will not break like glass. Okay, for example, okay, metal, aluminium. For example, aluminium or any metal, you can bend them. You can bend them. If you can bend them, or tak bend. If you can bend them, that means from straight becoming like this. So that means that material is ductile. If you cannot bend them, for example, mirror or glasses, when you hit with something, it will just break into pieces. That means that material is brittle. So the opposite is brittle. But for metal and alloy, the properties is ductile. Okay, good thermal and electrical conductors. Of course, electron can flow within the substance of the metal. And when you use sandpaper, the metal will be shining. Okay. So the classification, it has one. First is ferrous metal, and the second is non-ferrous. So ferrous metal typically are the metal that is higher in weight. The non-ferrous is low in weight. For example, aluminium, copper, titanium, nickel, everything. This is periodic table. Periodic table which you have met when you are in your secondary school. And non-metal element. This is the shaded with blue is metal element lah. The non-shaded is non-metal. Metal and non-metal. This is non-metal. The blue one is metal. Application of metal element. First, to make bridge. This is Golden Gate Bridge in California, United States. This is aircraft turbine engine and other smaller things that can be made using metal. Okay, we go to ceramic. Ceramic is inorganic substance. Okay, consists of metallic and non-metal, chemically bonded. For example, Si, for example, titanium oxide. So titanium is metal element, oxide is non-metal element. Okay, so this combination will produce a high strength material. So this is advanced ceramic lah, a very high strength material, and this it can be used as a cutting tool lah, as a cutting tool to cut something, typically to cut metal. Okay, the properties are high hardness, high temperature strength, little like you know porcelain, 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 porcelain. Plate. So it's very brittle, lightweight, high strength. Then very all positive properties. Okay, lightweight, brittle, high strength, strong, something like that, everything. Ceramic. This is the metal and non-metal. So the application ceramic material, the first application, uh, this one like this lah. Toilet bowls, what else? Sinky, sink. The ceramic lah, the white sink. The ceramic is very good surface finish and very shining. So they use this kind of material to make that. The second application, which is the popular one, is bio. This is a biomaterial, all these things. We call it bio plus material. So it becomes biomaterials. Biomaterials are the material that has or that can be applied to human body, inside the human body or animal body. So any material that you can apply inside our body, it will become biomaterial. So it is the combination of bio and material. So it becomes biomaterial because why ceramic is suitable to be used as a biomaterial, because in our body we have fluid, water, blood, okay, and we cannot use metal. We cannot use metal in our body because metal is corrosive and it can rust. Okay, it can rust. Dia boleh berkarat metal. But ceramic is the corrosion resistance is very high, so dia tak berkarat. So that is why ceramic is suitable to be used as a biomaterial. So if you break your bone because of the accident or whatsoever, your bone can be replaced using ceramic. Okay, polymer consists of organic long molecular chain or network. So the properties can vary from one polymer to another polymer. So some polymer is high strength, some polymer is very elastic. For example, rubber is very high elastic. Some polymer is not that high elastic. Okay, so depends. Very strength and very ductility, good insulator, low density, not too heavy, and low certain temperature, only up to 200 degrees Celsius, something like that. It can melt or it can become very soft. Okay, this is the application of polymer to make bottles, to make a disjoining a pipe, or pipe also, can be made using polymer and other thing lah, that like these simple things. Okay, composite material made up of two or more distinct material, matrix and reinforcement. Example, concrete. Concrete. So you want to make a building. Okay, the building should have a pillar. Pillar. So the pillar, inside this pillar, before you pour cement, you put steel bar, or we call it rebar, reinforcement bar. You know steel. There's steel, and then you pour you pour cement, so it will become a concrete. Okay, so that cement holding the steel bar. So that is why that a concrete is very strong, because inside there is a steel bar. But the steel bar alone cannot take off if it stands alone. So you have to combine with concrete, with cement to become concrete. Faham tak? Other types of composite include, this one is polymer matrix composite, metal matrix composite. This one is matrix composite. Okay, application of composite material. First is to make boat or yacht. And can use to make this one bicycle frame, because it is high strength and it is lightweight. And then a rotor blade, no, not rotor blade, helicopter blade. This one, the called the deck things. It can make using composite. And then also the body of the car, of the racing car, carbon fiber plus epoxy. So this is composite. It is high strength, but it is like, and other application is ni lah, apa nama dia? Aerospace. And then electronic materials.
You can hear your voice clearly.
What's your question?
We can't hear your voice clearly just now.
My voice. I think my voice already maximum. My speaker already maximum.
I mean, the connection is poor.
Oh, okay. If I change this, it will be, I will be disconnected. So better I don't change. Faham tak? I will be disconnected. So we try to cope. This one is not that important. This is microscope electron. I don't know why this light in here. Then you have smart material. Smart material, you have like a piezoelectric material, shape memory alloy, chromoactive material, magnetorheological material, photoactive material. Okay, so smart material are the material that are manipulated to respond in a controllable and reversible way, modifying some of the properties as a result of external stimuli such as certain mechanical stress or certain temperature, among others. So if you want if you want to remember what smart material is, you can just say that the smart material is the material that will respond according to its environment. So what environment? If you give stress or if you give uh, a physical environment, the changes, the material will change. The material will change. I can show you example. You can see my YouTube right now. Can you see my YouTube?
Yes.
Okay. This is an example of smart material. Okay. This is cup lah, cup or mug. So now it is cold. It is cold, but when you pour a hot water into the mug, into the cup, the mug color will change. So that is an example of smart material lah. So change because of the condition of the heat. And this one is the clothes. This t-shirt also will change in its color when it is exposed to heat. So this guy give hot air from the hair dryer to the t-shirt, and the t-shirt will change its color. Okay, this film also detecting human parts because we have blood in our body. So the blood, so it detects the blood because the blood has some temperature, so that's why it changed. So same to this spoon. So when this touch water, the color will change. So this is an example of a smart material lah.
Awesome.
Okay, and we also have shape memory alloy. Okay, shape memory alloy is the alloy or the metal in which that it will change when it is exposed to a certain temperature. So when first initially the shape of the alloy could be like this, but when you put in a hot water, the shape memory alloy will become straight. We can look at the example shape memory alloy. Okay, this one is easy example. I just give you easy example.
So memory metal is called nitinol because it's a alloy of nickel and titanium. So what's cool about it is that you can twist it in any shape that you want. Twist it all up, and if you just stick it in warm water, whoa, it shoots right back straight. It does it.
See, when you this shape memory alloy, when you bend and then when you bend them and then you put in the hot water, it will become straight because it change according to the heat of the from the water.
Twist it all up, and if you just stick it in warm water, whoa, it shoots right back straight. It does it pretty forcefully.
Okay, I think we should continue the lecture next week. That's all for today. Okay, have a nice day.
Doctor,
Yes.
can I ask, is it available for us to revisit this study material?
Revisit. What do you mean revisit?
Maksudnya yang kita dah belajar tadi kan, example like the slides that you have presented just now, kita orang boleh tengok balik ke?
Masa awak recording ni ke?
No, not the recording, the slide. Maksudnya yang
I think it's like
okay, alright.
oh okay. Actually the slide I have given in WhatsApp group. Maybe you are quite late. Join the group, but you didn't receive. But I can forward again, and also I will upload into Kalam. But I will send to you now. I send you now.
Alright, thank you so much, Doctor.
You already in the group WhatsApp, right?
Yes, Doctor, I already in the group WhatsApp.
I am transferring now. So okay, I will transfer now. Okay, see you next week. Yeah.